Hi, good afternoon. I'm going to talk to you today about something which we call a heat mat. So first question I guess some of you are going to ask is, what the hell is a heat mat? Keeping it very simple, you can see here in the pictures we've got extruded aluminium sheets. Within those sheets we build, at the point of extrusion, we build a complex internal structure. We then cap the things off, we fill it with a working fluid, so we have a fully contained system that is very, very fast, very, very efficient at transferring heat energy. So we rely on the fluid that goes into the matrix structure within the sheets. When it's heated, even just a few degrees, the fluid will vaporize. The vapor will rush throughout the rest of the matrix, carry in the heat energy with it. When it reaches a cooled part of the product, then it condenses, turns back into a liquid. So when it vaporizes in the first place, the vapor absorbs a huge amount of energy. When it condenses, it releases that energy. So we have a product here which can be used in many, many applications as kind of a superconductor of heat. So we all know about superconductor of electricity. This is a very similar base technology which can transfer heat hundreds of times more efficiently than any other substance any other solid material, so any other copper or any other material. So what are the applications for it? There are many applications. Those that we're developing at the moment include building materials. So you can use these sheets to build not only the roofs but whole houses potentially, but in a particular roof application we've had units on test up at the building research establishment whereby the whole roof are made out of these sheets, which are then covered with thin film PV. Now the way this works is we'll put a cooling system at the apex of the roof, so we're taking energy away from the sheets at the apex of the roof. The gases inside are being heated by the sun and by the general air temperature, so they are turning into a vapor up toward the top of the roof. When the vapor hits the cooling system, it condenses. So we set up this whole continuous process of extracting energy from the air and bringing it into the building where it can be used to heat the building or provide hot water into the building. We've also looking at commercial refrigeration, and one of the first applications to go into production is likely to be commercial refrigerators. We replace the stainless steel shelving, which is really within a commercial refrigerator. It's there simply to hold the merchandise. We replace that with one of these heat mat shelves, and the shelf effectively becomes a part of the cooling system. So a small part of the shelf sits in the airflow at the back of the refrigerator. It's cooled by the cool air that's blowing up the back of the fridge, and the whole of the rest of the system looks to replenish the energy which is being taken away by the cool air blowing up the back. So the effect of that is any produce that's sitting, any merchandise that's sitting on the shelf has heat literally drawn out of it by the shelf. Also, air coming into contact with the shelf is immediately cooled, meaning there's a natural convection down onto the produce that's sitting beneath it. So, what we have here is the opportunity to take an existing refrigeration process where you're simply relying on one process. You're relying on the cold air to hit the produce to cool it. With this system, you've now got 3 different cooling processes. The net effect of that is we see savings in commercial refrigerators anywhere from 20%, which we reckon is the norm in the UK in our testing, but we got feedback from testing that's going on in China today where we saw a 54% reduction in the energy consumption of commercial refrigerators. The other application that we're immediately looking at is in electric vehicles. Another one of the problems with lithium-ion batteries is you get heat spots. We're building cradles for the batteries to sit in. Those cradles take any hot spot and it immediately transfers that heat across the whole of our panel. Some of that panel will sit in airflow, so what we have is a system where we take hot spots, we disseminate that heat around the whole of the panel, and as the vehicle's running, or there can be another cooling system which then removes that heat completely. That's just 3 of the applications that we have. We are looking into many other applications. There are radiators for building temperature control. We've got chirogenic applications. We've got some catering applications where you can remove hot spots on commercial hot plates that are used in fast food areas, so you don't have any burning, so we reduce carcinogens potentially in cooking. Lots and lots of different applications. We have no time left, apparently. So that's me just about done. Thank you very much. Cheers. That's all right.